And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. But before that, if you have not subscribed the channel yet, please subscribe the channel and like the video. Okay, alright, let's start with today's problem, which is find median in a stream which is marked as a hard level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given one array ARR of integer type and its length can be as long as 10 raised to the power 5. Okay, all right. And now what we have to do, we have to return the median for every element of this array. Okay, so we have to treat this array as a stream. Okay, all right, we have to treat this array as a stream. What does this mean? This means, suppose first of all I got 5 from this array, like first element is 5. Okay, now I have to tell the median of this array. So currently my array is only 5. Its median will be what? Its median will be 5. Okay, after that my array is 5 15. After that my array is 5 and then 15. Okay, now what will be the median? If there are even size, you can read these cases. There are two cases for median. If the data has an odd number, then the middle one will be considered as median. But if the data has even number, then like there is no middle, because if there are even number, let's suppose these all are the even numbers. So what is the middle? Nothing is middle. What will be the middle? In that case, what will be the median? Arithmetic mean of the two middle values. So these two values mean will be our answer. Okay, will be our answer if the array size is even. Okay, all right, so let's quickly calculate the median. Then for 515, the median will be the mean, arithmetic mean of the two. 515 20 divided by 2, which is 10. Okay, all right, so 10 is this case. Now again, after that 1 is added to the array. So now my array will be something like 5 15 1. Okay, now what will be the median? You will be saying ki yaar, middle one will be the median, so 15 will be the median. But no, median we always calculate for the sorted array. Okay, so is this array 5 15 1 sorted? No. So first of all I will sort it. Now my array will become something like 1 5 and then 15. Okay, now what is the middle one of this? 5. So 5 will be our answer. Okay, moving on. Now 3 is added, so our new array will be something like 1 3 5 15. In this case, what will be the median? Median will be the arithmetic mean of middle values is 3 and 5, which is 8 divided by 2 4. So 4 will be the answer. Okay, after that again I again this 2 will be added. So now our array will become something like 1 2 3 5 15. Now which is the median? Odd is there, so middle one, which is 3, will be our answer. After that 8 is added. So in this way elements will be added, and for each element added, like for each index of this array, suppose my I is at this 3, so I have to tell the median of these array. Okay, after that 2 is added, so when 2 is added I have to tell the median of this array. After that 8 is added, so I have to tell the median till, like, from 0 to I, from 0 to I elements median I have to tell, and we have to return it into an array list of double. Because look, uh, suppose 3 comma 4, so what will be the median of it? Its median will be in decimal, like 3.5 something. So that's why we have to return in double. Okay, all right, I hope the problem statement will be very very clear to you. Now let's think of the approaches. Okay, first approach is the very very brute force approach. What I'm going to do, we will simply make a priority queue, and or we will make an array list. We will make an array list, and when first of all 5 is added, after adding 5 I will sort this array. Okay, after adding 15, again I will sort this array. After adding this 1, again I will sort this array, something like, now after sorting it will become 1 5 15. If the length is odd, return the middle element of this array list. If the length is even, return the middle to arithmetic mean. So we can do this, we can very very easily do this, but the time complexity will be very much, because for each length of this array I am sorting this array. So in sorting it will become, it takes n log n time, and suppose I'm doing it for m times, so it will be something like m into n log n, which is like n square time complexity n square log n, and it will give me time limit exceed for Sure, it will give me time limit exit. So we have to make it better. We have to make it better. Now, how can I make it better? There's a very beautiful approach for this. Now let's move on to the one note section. But before that, like I am making it sure that you guys have understood the problem statement. If not, please rewind this video again. Okay. All right. Now let's think of the optimized approach. The optimized approach, what I'm going to do is very, very simple. I'm going to take two heaps. I'm going to have two heaps. First one will be a max heap. Max heap basically means a priority queue with reverse order, in with elements stored in reverse order. It will be my max heap. Okay. Then there will be a min heap. Min heap will be containing what? Min heap will be containing in like sorted order. It will be in reverse sorted and it will be in sorted order. Okay. All right. So now what I'm going to do, I'm going to do something like ki yaar, uh, at at any point, till any point, the suppose this is a one array which is sorted and this is its half. So the first half which are less elements will be present in max heap, and the half which is greater than that will be present in min heap. Okay. All right. So in that way, at any point my median will be the, if look, if the number of, or total number of elements are odd, in that case my max heap peak will be my answer. Otherwise if min heap, if both the size are equal, max heap and min heap size are equal, so our answer will be the mean of the average of max heap dot peak and min heap dot peak. Okay. All right. I understand it is becoming a bit tricky at the moment, but let's quickly do a dry run of it, and I'm going to keep on explaining with the dry run and it will become crystal clear to you. Okay. All right. So first of all, max heap and min heap. Now first condition will be ki if max heap is empty, first element will be added to max heap. Okay. And this is my answer array list which is currently empty. Okay. So first element which is empty, it will be added to max heap. Okay. All right. Now my first element is added, so I have to add the median for this element as well. Like for till 5, what will be the median? Till 5, if look, you have to understand the condition. Find median condition is if max heap dot size is greater than min heap. If max heap dot size is greater than min heap, my answer will be max heap dot peak, because I will tell you, let's quickly go on and on. So for this, answer will be 5. Okay. All right. Now 15 is there. So look, max heap currently is 5. Now any element which is greater than this peak, any element which is greater than this peak will go in min heap. So 15 is there. Okay. 15 will go here. Now at this point 5 and 15, two elements are there, and now median will be what? If you remember, max heap dot peak plus min heap dot peak divide by 2, which is 5 plus 15, 20 divided by 2, 10 divided by 2, which is 10. Okay. All right. After that, again 1 come. Again 1 come. Okay. All right. So now 1 come. So if you remember, I told ki yaar, max heap will be containing elements in the left half, and min heap will be containing the elements right half. Okay. So left half, look, 5 is there. Now 1 comes which is less than 5, so it comes in the left half. I hope you guys are getting. So left half, it will be stored in max heap. Now in max heap, it will be stored something like this. Why? Because max heap is stored in reverse order, sorted reverse, descending order, I can say, decreasing order. Okay. And this will be in increasing order. Okay. All right. So 5 1. Now if you remember, I'm saying ki yaar, if max heap dot size is greater than min heap, which is currently there, max heap dot size is greater than min heap size, and that case my answer will be max heap dot peak. So again it will be 5. Okay. All right. Moving on. Now I got 3. I get 3. Okay. So look, again it will be added in the max heap. Why? Because 5 is the peak. If any element which is less than the peak, it will go in the max heap. Okay. 3 is added. Now you can see, yeah, my max heap is like this. These are unbalanced, because now again I have to, my answer will be what? 5. According to current logic, max heap size is greater than min heap, so my answer will be 5, which is wrong. Now what I have to do, I have to balance min heap and max heap. I have to balance min heap and max heap. How? If at any point max heap size max heap size is greater than min heap plus 1 size. Okay, in that case what I am going to do, I'm going to remove the top element from max heap and add it to min heap. Okay, so it will be added something like this, 5 comma 15. Okay, and 5 is removed from here. 5 is removed from here. Okay, why I am doing this, if you remember, I think you guys should listen it very carefully, because now my max heap and min heap size is equal, and now my median will be what? Max heap dot peak plus min heap dot peak divided by 2, which is 538 divided by 2, which is 4. Okay, so at any point, if my max heap dot size is greater than min heap dot size plus 1, I will look, max heap size is greater, so remove max heap peak and add it to min heap. Okay, all right. Otherwise, if my min heap size is at any point greater than max heap, in that case I will remove from min heap and add it to max heap. Plus 1 I am giving to max heap because uh, look, it can be vice versa as well, but max heap size I am adding plus 1 here, so that if at any point my max heap size is greater than 1, in that case I will directly return max heap dot p. I hope you guys are getting this point. So now I got 2. Again, 2 will be added to max heap. Why? Because 3 is now peak. So if any element comes which is less than max heap dot peak, it will be added in the max heap. Okay, so 2 is added. Now 2 will be added in decreasing order, so it will become something like 3 2 1. Okay, all right. Now what will be my answer? Max heap dot size is greater than min heap. Answer will be max heap dot peak, which is 3. So that's why you remember I'm giving this plus 1 advantage. I'm giving plus 1 advantage so that in this case it runs. But if one more elements get added here, in that case I will not add. Okay, all right. So now the next element, which is last element, which is 8. Okay, all right. Let's add 8. So where 8 will be added? If max heap dot peak, my new number, is less than max heap dot peak, it is less, in that case it will be added in max heap, otherwise it will be added in min heap. So let's add it in min heap. Now it will be added in 8 here, but like min heap is there, so it will be in increasing order, so it will become 5 8 50. Okay, all right. Now what I'm going to do, min heap and max heap size is equal, so my answer will be the median, or the mean max heap dot peak plus min heap dot peak divided by 2, which is 538 divided by 2, which is equal to 4. So this will be my median answer list. I hope it is very clear to you. So if yes, make sure to subscribe the channel and like the video as well. And yeah, so in this way you can take as many examples as you want, and you will always get the required answer. What I'm doing here is just adding. Look, first of all I will add one element based on the condition I have already told. If the current number is less than max heap or equal to max heap, it will be added in max heap, otherwise it will be added in min heap. So first one is the addition. Second one is what? Second one is balance. So balance logic I have already told. And after that, when addition is done, balancing is done, find median. Third step is find median. Okay, so in this way you can take many examples if you are not satisfied with it, and you will always get the correct answer. Okay, so now let's move on to the code section. But before that, if you have loved the explanation till this point, make sure to subscribe the channel and like the video, share it with your friends, and comment down how was the explanation, because you can see I'm making this video at midnight at 2 a.m. So I think I deserve a subscribe button. Okay, subscribe. Okay, all right. So let's quickly move on to the code section. First of all, I'm going to make array list of double, which will be my answer as well. Let's name it result new array list. Okay, all right. And now I will be making two heaps. First one will be max heap and second one will be min heap. Okay, let's quickly make it array list of integer, and let's name it as max heap. It will be priority queue. So heap is implemented using priority queue in Java. Okay, so something like this. Let's copy this. I will remove, close this as well, and now let's quickly write it. New priority queue, and now a max heap will be in reverse order. So how to write in reverse order? Collections dot reverse order. Okay, something like this. Now again another priority queue will be created, but this time it will be min heap. Okay, so let's quickly copy this again and name change it to min heap, and this time it is simple priority queue. Okay, so this is done. Now what I'm going to do, for each element, let's do int num of arr. I'm going to do two steps. uh, First one is add number. Okay, add number to what? uh, First of all, I will pass my number, and then I will pass the two heaps, max heap and min heap. Let's pass them max heap and min heap, something like this. And after that, what I'm going to do, I'm going to find the median. So result dot add uh, find median. Okay, all right. And here I'm just going to pass two things, max heap and min heap. So after that, when all of these are done at 43 line, I will simply return result. Okay, so if you remember, I told there will be three steps. So balancing the tree, I will add it in add num function only. Okay, so let's quickly implement first function, which is add num. It will not be returning anything, and its name will be add num. It will be expecting few things. First one is int num, and after that it is expecting two heaps. So let's take it something like this, and after that like this. Okay, all right, so let's add it. So if you remember, first step is if max heap dot is empty. Okay, or max or if look, or it's in lies in the left half. How can I tell if the number lies in left half? If number is less than or equal to max heap dot peak. Okay, so in these both cases I will add it to max heap. Guys, I hope you are with me, and I'm just going to write what I have explained. Okay, so I'm going to write max heap dot add number. Okay, otherwise it will be added to the min heap. So min heap dot add num. Okay, all right. So like this is the logic to add. Now I have to balance it. How I am going to balance it? Very easy. It's very easy. If max heap dot size is greater than min heap dot size plus 1. If you remember, I told I will give plus 1 advantage to max heap, because I am expecting here if max heap size is greater by 1, it will be, my answer will be max heap dot peak. Okay, so I'm giving it 1 advantage. And if like it's if max heap dot size is greater than even plus 1, in that case I will remove one element from max heap and add it to min heap. Okay, so let's quickly do min heap dot add what? Max heap dot pull. Okay, so whatever it will be removing, it will be added here. Otherwise, let's copy this only. Else if uh, min heap dot size is greater than max heap dot size at any point, I will be doing max heap dot add min heap. Okay, so in this way it is balanced as well. All right, now moving on, the last step is remaining, which is what? Which is to find the median. Okay, so let's quickly make it double. It will be returning double, and the function name is find median. It is expecting two things, which are both priority queue, max heap and min heap, something like this. And after that, very easy it is. Look, if you remember, I'm giving plus 1 advantage to max heap. So if max heap uh, sorry, let's copy this max heap. If max heap dot size is greater than min heap dot size, in that way what will be my answer? It will be simple, max heap dot peak. So return max heap dot peak. Okay, otherwise what will be my answer? the mean of average, the mean of max heap dot peak and min heap dot peak. So let's do that. How I'm going to do? Return, very easy. It is max heap dot peak plus min heap dot peak, and it will be divided by 2.0, because look, I have to return in double, so I'm just doing type 2.0 so that the whole answer is converted to double, and that's it. Let's quickly try to compile this. I hope I have not done any silly mistake, and I've explained this bit by bit. So max head, okay. Oh, max head, I've written max head at many places. Let's make it heap p p 3. Okay, let's quickly try to compile this again to check. Okay, it's getting compiled successfully. Let's try to submit this. Meanwhile, please subscribe the channel, like the video, and share it with your friends if you have loved the explanation. And I think it is getting accepted. So yeah, that was it for today. Please sit with pen and paper and try to dry run it as many times as you want. And yeah, I'm going to see you again tomorrow. Till then, keep on coding, subscribe the channel, like the video, and bye.